Not quite done with everything that makes water so unique. Another very important characteristic of water is that it changes temperature really slowly, right? Like if you were trying to get something really hot, like if you have a rock that you're putting by a fire versus water of the same mass. Water actually takes a lot of energy to change its temperature, more than pretty much anything else. And it may seem like, hard objects or dense objects like metals would take more energy to get hot. But in fact, water actually takes more energy to get hot than just about anything else. And this is really important because the human body is mostly water, and this helps us insulate against changes in the external temperature, right? It helps protect the body from rapid temperature changes, and it's important for explaining a lot of ailments that could be happening and for our success as a species. During a fever, right, your body makes extra heat, and because there's so much water in your tissues, the temperature rises more slowly. Water's role in the body continues to be multifaceted and very important. When we compare water to other liquids, right, like gasoline or like oil or like, any liquid you can think of, right? Water is better at not changing its temperature compared to any of these other ones. And this is another reason why water is so important in your body, right? Cooling, sweating, using cool cloths, things like that. Water is again key for this same reason. When we sweat, water in sweat absorbs a lot of heat from the skin as it warms up and then evaporates, right? We basically let out a little bit of water, and that water ends up warming and evaporating. Well, that warming and evaporating has to take energy from somewhere, and it takes it from us. And so when we sweat and that sweat evaporates, it cools us off because it's drawing heat out of our bodies, and it draws quite a lot of heat because, again, water is pretty resistant to temperature changes. It takes a lot of heat with it when it evaporates. One last thing, solid water floats on liquid water, right? Ice floats. If you'd have a glass of ice water, you'll see that the ice tends to float. And this is very unusual behavior, right? When we have things that freeze or become solid, they tend to become more dense. However, water is unique because it actually gets less dense. And this is because of that hydrogen bonding network again. There's so many interactions between the waters in the liquid phase that they're able to draw in really close. When we force them into position in a solid form, the ice actually swells a little bit. And so, this is, again, very unique, but also very important to life on Earth, right? When we have liquid water, it forms ice, it gets less dense, and the ice floats. And this is really important because when we have winter come along, well, the ice floats on the top. And the fish below, they're protected from a top layer. They're living in the water. That's fine. If instead we have ice forming on top, descending like a wall pushing in, that would probably not allow for life to exist in the deeper areas of lakes and things. All life began in the water. Life evolved in the water and then emerged to land later. Once again, water is showing that it has a lot of impact on this eventual creation and sustaining of life on planet Earth.